A battery is a power source consisting of multiple cells in series. So batteries are used when more potential difference is required than a single cell. The circuit symbol for a battery is multiple cells connected in series, connected positive to negative. Sometimes a dotted line is used to represent cells together in a battery, with the notch at the positive end. But what is the potential difference of a battery, and how does it relate to the potential difference of the cells? The potential difference of the battery is the sum of the potential differences of the individual cells, so all we need to do is add the potential differences together. For example, if we have a cell of 6 volts, one of 3 volts, and one of 12 volts, all we need to do is add the potential differences together to get a total potential difference of 21 volts. But this rule only works when the cells are correctly aligned. So what happens when we change the direction of one of the cells? Well, if a cell is connected in the opposite direction, then its potential difference will instead be subtracted from the total. So in the same way that we define a conventional current, we have to define a positive direction for the potential difference. Let's have a look at another example. In this example, we have the same cells of 6 volts, 3 volts, and 12 volts potential differences. But in this example, the middle cell has its potential difference reversed. So in this example, we have to subtract the 3 volts as the potential difference is now negative. So the potential difference of the battery now becomes 6 volts minus 3 volts plus 12 volts to give us 15 volts. Let's have a look at another example. The diagram shows a circuit with 4 cells connected in series with a lamp. Calculate the potential difference across the lamp and the direction of the current through it. So we can find the potential difference and the current of the lamp by looking at the total potential difference and the direction of each cell. So for the first step, we want to find the total potential difference directed clockwise. So that is 4 volts and also 12 volts. So 4 volts plus 12 volts gives us 16 volts of potential difference directed in the clockwise direction. For step 2, we want to find the total potential difference directed anti-clockwise. So that is 6 volts and also 8 volts. 6 volts plus 8 volts gives us 14 volts in the anti-clockwise direction. Then for step 3, we want to determine which direction has the greater potential difference to determine the direction of the current. So we can see that the clockwise direction has a greater potential difference, so the current is clockwise. Then for the final step, we want to find the difference between the total potential differences to find the potential difference across the lamp. So 16 volts in the clockwise direction minus 14 volts in the anti-clockwise direction gives us 2 volts of potential difference across the lamp.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!